Welcome to Physical Science, Module 15A. We're going to be talking about the dual nature of light. We'll be covering particle theory, wave theory, electromagnetic waves, dual nature, and quantum mechanical theory of light. Light is a fundamental part of creation, and it's one of the first things mentioned in the Bible. Genesis 1, verses 1 through 4a says, "Then God said, 'Let there be light,' and there was light. God saw that the light was good." Without light, life could not exist. Most common waves in creation are electromagnetic waves, and electromagnetic waves include light. This is a drawing that you will see over and over that is an image of a light wave, and it's actually two waves together, so we'll be talking about that. So in 1704, Isaac Newton wrote about particle theory. He felt that a beam of light behaved the same as a stream of particles, that they were all moving in the same direction. Around the same time, another scientist named Huygens concluded with his wave theory that a light was a wave, not a particle. By the early 1800s, most scientists accepted his theory and believed in wave theory over particle theory. Then Maxwell came along, and we've learned about Maxwell previously, and he stated that light waves are actually composed of two perpendicular waves working together to produce light. So you have magnetic waves that are in blue here, and electric waves that are, or light waves that are in yellow, and they pass each other in a perpendicular manner. If you can see this, there's a piece where when they cross over, it forms 90-degree angles. So they work together to produce light, and you have an oscillating electric field and an oscillating magnetic field. Maxwell's view of light explains how light can travel through a vacuum. So, because we are combining the properties of both of these types of waves, which we'll now call electromagnetic waves, we can see different properties that come from this view. Light is composed of electric and magnetic fields, so light travels not affected by atoms or molecules in the vicinity, so nothing gets in the way of them. It might slow them down, but they still continue on. The wave is composed of electrical and magnetic energy that oscillates back and forth, resulting in the electromagnetic waves. And just as an interesting aside, I just read that they're using electromagnetic waves to bombard the brains of Alzheimer's patients, and it's breaking up the proteins in the brain that have caused them to begin to lose brain function. And it doesn't have side effects like drugs do. So this is a really interesting way to use these waves, and kind of an offshoot of them having used them for things like breaking up gallstones and kidney stones. So we'll see what happens with these waves in the future, as far as medical concerns go. So an electromagnetic wave is a transverse wave composed of an oscillating electric field and a magnetic field that oscillates perpendicular to the electric field. So this is the basic description. Scientists believe that electromagnetic waves have a dual nature. Light has wave-like characteristics, and it also has certain particle-like characteristics that can't be explained if light is only a wave. So there's things that we already knew about light that couldn't be explained by the characteristics of particles. And this led scientists to further examine light and discover that it has these dual properties. This moves us on to the quantum mechanical theory of light, where light is viewed as packets of waves. So each packet can be thought of as a particle or a photon. Each packet can also be thought of as packets of electromagnetic waves. And sometimes light will behave as a particle, and sometimes it will behave as a wave. An interesting aspect of this theory is that with computers, data is actually transmitted as packets. And they use lasers in computers now to help transmit those packets. This technology actually helped with the invention of the internet. So they're all tied together. Speed of light. Light does not need atoms or molecules to travel. As a result, light can travel through any region of space regardless of what occupies that portion of space. Remember that light travels a lot faster than sound. Sound is dependent on temperature, but light is not. So the speed of light. In a vacuum, wave packets travel at 300 million meters per second, which is about 670 million meters per hour. Sound travels through, 670 million miles per hour. Sound travels through air at 340 million meters per second, which is 760 miles per hour. The speed of light does depend on the substance it travels through. And the speed of light is fastest in gases, slower in liquids, and even slower in solids. So these are 3 facts that you do need to know. Here's a chart that will help you to remember about the speed of light. And it shows in the chart that, and you can see here with air, speed of light is 300 million meters per second. But when it travels through a diamond, it's reduced to 125 million meters per second. This is because diamond is solid and it's dense, and the denser the material is, the more difficult it is for light to get through. Albert Einstein developed a theory known as the special theory of relativity. He did this back when he was doing the other theories that we've learned about. He said that the speed of light in a vacuum represents the maximum speed that can ever be attained by any object that has mass. Nothing with mass can travel faster than 300 million meters per second. He stated that the speed of light is the ultimate speed limit. If this theory is true, that means that many of the science fiction movies we have read have watched are factually not true. You'll see in a science fiction movie where they have something happen to their ship and suddenly they've traveled 400,000 light years away in a matter of seconds. This is something that people would like to happen, but at present there is no science that has been discovered that tells us that we can travel faster than the speed of light. Believe me when I say, though, that they are working on it. We would have to have faster than the speed of light to be able to travel to other galaxies. So it is something that they're looking at for our future. So that's the end of this piece of Module 15. If you have any questions, be sure to contact me. Go on to on your own problems and your activities. And we'll talk again in the next video.